So the next question, okay, problems, continuity part 2. So I'm discussing problems in this session. The question is, find the points of discontinuity of the following functions. So we have to find points of discontinuity of these functions. So basically 2 sin x minus 1 is continuous function at every real number. But here it is 1 upon 2 sin x minus 1. So clearly this function is a continuous function in its domain only. So that means it is discontinuous at the points where it is not defined. Okay. So clearly this function is not defined, or this function is discontinuous when denominator 2 sin x minus 1 is equal to 0, or sin x is equal to what you will get, 1 by 2. So 1 by 2 can be written as sin pi by 6. So one of the point of discontinuity is pi by 6. X is equal to pi by 6. So for x is equal to pi by 6 only sin x is 1 by 2? No. There are many x values. There are many x values for which sin x value is 1 by 2. So what are those x values? So that is nothing but that how we can obtain that one means just you find the general solution of this trigonometric equation. So sin x is equal to 1 by 2. Further general solution is what? X is equal to n pi plus minus 1 whole power n into alpha. What is alpha? Principal value. What is the principal value here? Pi by 6. Or you can write x is equal to 2n pi plus pi by 6. One solution. X is equal to 2n pi plus 5 pi by 6. That is also one solution. Union of those two solutions gives this. Okay. So sin x is equal to 1 by 2 general solution. This is the general solution. So where n is integer. So if you take n value 0, pi by 6. If you take n value 1, 5 pi by 6. So like that, how many solutions will get? Infinitely many. At all those points, this function is discontinuous. Next, second question. F of x is equal to 1 upon x square 3 into mod x plus 2. So clearly this is also a discontinuous function. Here this function is also discontinuous function when denominator is 0. So x square can also be written as mod x whole square. Okay, x square can also be written as mod x whole square. So now it is a quadratic in mod x. Just to find the factors, what you will get? A mod x minus 1 into mod x minus 2. So implies that mod x is equal to 1 or mod x is equal to 2. So x is equal to plus or minus 1. Mod x is equal to 2 implies that x is equal to plus or minus 2. So that means the given function is discontinuous at 4 points, which are plus or minus 1 and plus or minus 2. So this is also some interesting problem. F of x is equal to 1 upon x square plus x plus 1. So it is a clearly rational function. This function is defined. This function is continuous wherever it is defined. So clearly this function is discontinuous when denominator is 0. Okay. So but if you observe the denominator x square plus x plus 1, we can write it as x plus 1 by 2 whole square plus 3 by 4. So is it possible this quantity is equal to 0 for any x value? See, if you take any x, any real x, this value, minimum value is 0 plus 3 by 4. That means if you substitute any number, instead of x, if you substitute any real number, then denominator minimum value is 3 by 4. That means you will get a number which is equal to 3 by 4 or more than 3 by 4 only. That means this denominator is never equal to 0. As this denominator is never equal to 0, then this function is never discontinuous. This function is never discontinuous. This function is never discontinuous means this function is continuous everywhere. This function is continuous everywhere. That means it is a continuous on R and discontinuous on empty set phi. because this is nowhere discontinuous. Next, one more interesting problem. So f of x is equal to step of step x minus step of x minus 1. See, by looking this integral part, don't say it is a discontinuous at integers. Okay, so first you try to simplify. So we know that step of any integer is equal to that integer only, and also for any real x, step x is integer. So clearly for any real number, this is an integer. So step of an integer is equal to what? The same integer. So it is equal to the same integer. What is that integer? Step x. Suppose if x is any number, step x is some integer. So step x value, suppose 5. Then step of this 5 only na? So that 5 is nothing but what? Step x. And also here 1 is integer, then step of x minus 1 we can write like this, step x minus 1. Because here 1 is integer. Suppose if it is x minus 1 by 2 is there, we can't write step x minus 1 by 2. Okay, step of x minus 1 by 2 not equal to step x minus 1 by 2. But here step of x minus 1, can we write step x minus 1 because of 1 is integer. Now here plus step x minus step x get cancelled, minus into minus, plus 1. So what we got, f of x, a constant function. So constant function is continuous everywhere. So what are the points of discontinuity of this function? Empty set. Next. So next problem, f of x is equal to 1 by 1 minus e power x minus 1 by x minus 2. 1 by 1 minus e power x minus 1 by x minus 2. So we have to find points where this function is discontinuous. So clearly it is discontinuous when x minus 2 is equal to 0 and also denominator is equal to 0. That is, it is discontinuous at x is equal to 2 and 1 is equal to e power x minus 1 by x minus 2. So e power this x minus 1 by x minus 2 is 1, means 1 can be written as e power 0. That means x minus 1 by x minus 2 must be equal to what? 0. So that implies x minus 1 0. So x is equal to 1. So thus this function is discontinuous at x is equal to 2 as well as at x is equal to 1. Next. So now I am dealing the problems. Here already function is continuous at given points. Then what is the unknown value? Okay. So f of x is defined. Next problem. F of x, it is defined e power x minus 1 whole cube into cosecant 3x divided by log of 1 plus x square when x not equal to 0 and its value is b when x is equal to 0 is continuous at 0. Is continuous at 0. Then find that b value. So it is given already this function is continuous function. That means the limit of the function is exist and its value is equal to value of the function at 0. So the value of the function at 0 is b. Now this b must be equal to what? Limit of this function at 0. So given f is continuous at 0, f is continuous at 0, then limit of the function is same as value of the function at 0. So limit of the function, limit extends to 0. What is f of x? X tends to 0 means x not equal to 0 only. So what is the function? E power x minus 1 whole cube cosecant of 3x divided by log of 1 plus x square is equal to f of 0 is what? B. So write this cosecant 3x is 1 by sine 3x. Okay. So B is equal to limit x tends to 0. E power x minus 1 whole cube divided by sine 3x into log of 1 plus x square. Now if you apply the limit, now till here continuity concept. Now to get b value we have to find limit of this problem. That means now we are using what? Limit concept. Okay. So if you apply limit, what you will get? 0 by 0 form. 0 by 0 form. So then what we have to use? L'Hospital's rule. But I told blindly don't use L'Hospital's rule. If it is easy, then you can apply L'Hospital's rule. Otherwise, try to apply some formulas. But here, it is not so easy to apply L'Hospital's rule because to eliminate this 0 by 0 form, we have to differentiate at most 3 times. So it is a very lengthy procedure if we apply L'Hospital's rule. Because denominator is in the form of u into v. For one time differentiation only you will get 2 terms. For 2 times differentiation 4 terms. For third time differentiation you will get 8 terms. And it is very difficult to to write all those 8 terms. If one term is missing, the answer will be collapse. Answer will be gone. So here just you think about formulas. So we know that when x tends to 0, e power x minus 1 by x is 1. Sine ax by x is 1. Sorry, sine ax by x is a. Log 1 plus x by x is 1. E power x minus 1 by x is 1. Log 1 plus x by x is 1. Sine of ax by x is a. Okay. Using these 3 standard limits, I am going to evaluate this limit. Limit x tends to 0. So e power x minus 1 by x whole cube. That means the numerator I am dividing with what? X cube. So denominator also you have to divide with what? X cube. So how to, and I am splitting that x cube as x into x square. So sine of 3x by x into log of 1 plus x square by x square. See, x into x square, x cube, here also x cube. Okay. How we come to know split x into x square? Because the sine ax formula there. Divide with x is there, then only we can apply that formula. So that means we need to have here only 1x. Remaining 2x will be here. So it is also in the form of log 1 plus x by x. So this position and this position should be same, and that position should be tending to 0. See, whenever x tending to 0, this position also tending to 0 only. So we can apply that formula. So according to that formula, this value is what? 1. 1 power 3, 1. Here a is 3 and this formula is 1. So 1 upon 3 into 1. Particularly 1 cube divided by 3 into 1. What you will get? 1 by 3. So thus b value is what? 1 by 3. Next problem. So next problem, it is given that f of x is equal to cos x power cot square x for x not equal to 0 and is e power minus 1 by 2 for x is equal to 0. And in this problem, we have to check whether this function is continuous or not at x is equal to 0. We have to check the continuity of the function at 0. That means we have to check whether limit of the function, value of the function both are equal or not. So here what is the value of the function at 0? E power minus 1 by 2. So just you find limit of the function. If the limit of the function is same as e power minus 1 by 2, then we can say that the function is continuous at 0. Otherwise discontinuous. So just calculating limit of the function here only. Limit x tends to 0. F of x is equal to limit x tends to 0 cos x power cot square x. See, if we apply limit, what you will get? Cos of 0, 1. Cot 0, infinity. So it is in the form of 1 power infinity. So how to evaluate this kind of limits? So just you observe the part 3 or part 4 of the limits. So you will come to know that procedure. So I am writing e power limit extends to 0. Observe now. F of x cos x minus 1 base function minus 1 into exponent function. So now if we apply the limit cos 0 1, 1 minus 1 0, 0 into infinity form. Now it is reduced to 1 power infinity form to 0 into infinity form. Then you convert it into 0 by 0 form or infinity by infinity form and apply L'Hospital's rule or apply some formulas. Okay. So e power limit extends to 0. Then how to convert this is 0 into infinity form to 0 by 0 or infinity by infinity. So this is 0, this is infinity. Either you write this infinity as 1 by 0 or you write this 0 as 1 by infinity. So here in this problem it is better to write this infinity as 1 by 0. That means cot square x as 1 by tan square x. So cos x minus 1 divided by tan square x. So here you can apply L'Hospital's rule 2 times because tan x is tending to 0 only. When x tending to 0, tan x is tending to what? 0. And cos x minus 1 also what? Tending to 0. So now it is converted into 0 by 0 form. You have to apply L'Hospital's rule 2 times because your 0 power how much is there? 2 is there. So either you apply L'Hospital's rule or approach the formulas. Here I am approaching the formula. Okay. E power limit extends to 0. I am dividing numerator and denominator by x square. How we come to know x square only? Because this become a non-zero number after applying the limit only if it has denominator x square, because tan x by x is 1. When x tending to 0, tan x by x is 1. So tan square x by x square is tending to what? 1 square, which is 1. So divide numerator and denominator by x square, and in the numerator you take minus common. So e power minus as it is, and it is the standard limit. E power 1 minus cos x by x square when x tending to 0 is what? 1 by 2. And tan x by x is tending to what? 1 square. So 1 by 2 divided by 1 square, which is equal to e power minus 1 by 2. And it is same as value of the function at 0, e power minus 1 by 2. So thus this function is continuous at 0. Next to this is you take homework. F of x is equal to 1 minus cos 4x by x square when x less than 0, and it is a when x is equal to 0, and it is root x by square root of 16 plus root x minus 4. For x greater than 0. So E given is continuous at 0. Then find a value. So for this problem I am suggesting just you equate a left hand limit is equal to value of the function, you will get a value. Because instead of finding right hand limit, it is easy to find left hand limit. Next problem. So next problem. So it is given that f of x is equal to 1 plus mod sin x whole power a by mod sin x. This problem is there even in our material. For minus pi by 6 less than x less than 0, and its value is b when x is equal to 0, and its value is e power tan of 3x divided by tan of 2x for 0 less than x less than pi by 6, given that it is continuous function. It is continuous function at 0. It is continuous function at 0. Then what is a and b values? If it is a continuous function at 0, then limit of the function must be equal to value of the function. And according to the definition of the function, before 0, after 0, the definition of the function is different. So here, to get the limit of the function, we have to find LHL and RHL. And we have to equate LHL is equal to RHL is equal to value of the function, because it is continuous at 0. See here? So LHL. So what you will get? LHL, limit x tends to 0 minus 1 plus mod sin x whole power a by mod sin x. See here, it is again infinity, 1 power infinity form. Observe here. As x tends to 0 minus mod sin x is tending to 0. So 1 plus 0, 1. A by 0, infinity. So 1 power infinity form. Okay, particularly mod sin x tending to 0 plus. Okay. So it is 1 power infinity form. Then how do you evaluate? E power limit x tends to a, that means 0 minus f of x minus 1. So this is f of x then. This is f of x. F of x minus 1 means what you will get? Only mod sin x into g of x. So mod sin x is get cancelled. So limit x tends to 0 minus a. A is a constant. So it is same as a only. So e power a. So what you got? LHL? E power a. Next RHL. So limit x tends to 0 plus e power tan 3x by tan 2x. Okay. If you apply limit, what do you get? Tan 0, 0. Tan 0, 0. 0 by 0 form. So we can use L'Hospital's rule. Now also we can write this limiter in the here exponent. Okay, because it's some finite quality only you will get. Okay. So here 0 by 0 form is there, then you can use L'Hospital's rule. So what is tan 3x derivative? 3 into secant square of 3x divided by 2 into secant square of 2x. Then if you apply the limit, if you substitute x value 0, secant square 0, 1, denominator secant square 0, 1. So 3 into 1 by 2 into 1. So 3 by 2, e power 3 by 2. Now as f is continuous at 0, left hand limit is equal to right hand limit is equal to value of the function. What is the left hand limit? E power a. Right hand limit e power 3 by 2. Value of the function b. So e power a is equal to e power 3 by 2 means a is equal to how much? 3 by 2. And b is equal to what? E power 3 by 2. So same problem is there in our material also. In our material it is, we have tan 2x by tan 3x. Then at that time what you get here? E power 2 by 3. So a value 2 by 3, b value e power 2 by 3. Here tan 2x by tan 3x is there in our material. Okay. Next, this is also a different problem. See, now I am dealing all are some different model problems. So try to watch the video from beginning to end to understand all concepts. Okay. So it is given that f of x is equal to, it is defined f of x is equal to capital A into cos x plus b into sin x minus 5 divided by x power 4 for x not equal to 0, and its value is k for x is equal to 0. Here k is some finite number. Okay. It is a continuous at 0. It is continuous at 0. Then you have to find a plus b plus k value. A plus b plus k value. Okay. So it is given continuous at 0, just use the definition. If it is continuous at 0, limit of the function is equal to value of the function. First you write that step, later you can think about that problem, how to evaluate. Okay. So if it is continuous at 0, limit of the function at 0, that is the limit extends to 0, f of x is equal to f of 0. What is f of 0? K. So limit extends to 0, f of x means what you have to take? A cos x plus b sin x minus 5 divided by x power 4. It is equal to value of the function k. So till here it is, till this step we are applying continuity concept. Now here onwards limits concept only. That means what, from this step what you have to understand, limit of this function at 0 is exist and it is equal to some value, some number k. So limit of this function is exist and it is finite. So limit of this function at 0 is exist and is finite, and that finite value is some number k. Then we have to find a, b, also k. So to get k value we have to evaluate limit of the function. Okay. Also we have to find a and b. So how to evaluate this limit, this kind of limits? So these kind of problems I am not discussed in limits. So that's why I took this problem in continuity. Okay. So this problem can be done in two different ways using L'Hospital's rule, and one more method is expansions. So I'm using expansions because if you use expansion within in single step you get a, b and k value. But if you want to apply L'Hospital's rule, you have to apply L'Hospital's rule 4 times. So either use L'Hospital's rule 4 times or use expansions. So I'm using expansions here. So limit extends to 0, a into cos x expansion. Cos x expansion is what? 1 minus x square by 2 factorial plus x power 4 by 4 factorial plus and so on. But denominator highest x power is what? 4 only, na? So you stop till 4 or just more than 4. Remaining terms you can neglect for this kind of problems, because remaining terms after applying limit you will get 0 only. Okay. Plus b into sin x expansion is what? X minus x cube by 3 factorial. Next what you will get? X power 5 by 5 factorial and so on. Minus 5 divided by x power 4. It is k. So k is equal to, so now numerator is a polynomial, just you collect the like terms. So first I am collecting constant terms. Here a into 1, a. Here there is no constant term. Here 5. So a minus 5. Next to x terms. X term is what? bx. Next x square terms. Minus ax square by 2 factorial. Minus ax square by 2 factorial. I think the question I took wrongly. I think it should be ax cos x. Yeah. Sorry, it is ax cos x. Ax cos x. Then ax cos x. No, bx, sorry. It should be bx sin x. Bx sin x. You take bx sin x. Bx sin x you take, then only you get the answer. So I have entered wrongly. So question should be a cos x plus bx sin x minus y by x power 4. Okay. Now constant terms as it is, a minus 5. X terms you won't get, x square term next you will get. X square term here, a into x square by 2 factorial with the minus. So minus a by 2 factorial. 2 factorial is 2. Next bx into x, bx square. So b into x square. Next to x cube term you won't get, x power 4 terms you collect. So here x power 4 term, what you will get? A into x power 4 by 4 factorial, x power 4 common. 4 factorial is 24. Next b, bx into x cube by 3 factorial with the minus bx power 4 by 3 factorial, that is b by 6, 3 factorial is 6 into x power 4. In both terms x power 4 common, and remaining terms you can neglect them. because in the remaining terms are x power 6 you will get, and dividing with x power 4, dividing with the x power 4, what you will get? X square. But as it tends to 0, then x square tending to 0. So those remaining terms you can neglect. Now I am dividing by x power 4 for each and every term separately, because here remaining terms means here in the numerator remaining terms what you will get? X power 6 term you will get, x power 8 term you will get. After dividing with x power 4, numerator what is left? X square. So as x tends to 0, x square tending to what? 0. Next term also what? Tending to 0. That means the remaining terms you can neglect. No need to write here, because it is not subjective, objective. So we have to you try to find a and b values as early as possible. Okay. Now if you apply a limit, suppose if you observe, if a minus 5 is not equal to 0, so something by 0 what you will get? Infinity. So limit of this function what you will get? Infinity. But here it is given it is equal to what? K. So k must be finite only, because f is continuous at 0 means this k should be what? Limit of the function is equal to value of the function should be equal to finite quantity only. So k must be finite. So if it is not equal to 0, then this limit is infinite, which is wrong. According to the given data, f must be continuous and this limit should be exist and finite and is equal to the finite quantity k. So that means a minus 5 should be equal to 0. If you cancel x square and x square, so again with the same argument, minus a by 2 plus b, if it is not 0, not equal to 0, so non-zero by 0 what you will get? Infinite. So that means it should not be infinite now. That means a non-zero, it should not be non-zero. It should be equal to 0. If it is equal to 0, 0 by x square, 0. Okay. If it is not equal to 0, not equal to 0 by 0, what do you get? Infinite. But this limit should be what? Finite. So that means this coefficient must be equal to what? 0. This x square coefficient, after cancelling x square, this becomes some constant. This constant must be equal to what? 0. Now here x power 4 get cancelled. Now if we apply x value 0, then limit of the function becomes what? A by 24 minus b by 6. Okay. After cancellation of x power 4, now if you apply limit x tends to 0, then what is the remaining here? Only constant a by 24 minus b by 6. That is the limit of the function, and that limit of the function is equal to what? K. So thus k is equal to what? A by 24 minus b by 6. Now by solving these equations, you will get a, b and k and find a plus b plus k. From this a value 5, substitute b value 5 by 2 and substitute here also, you will get the answer. Next problem. So next, this is also interesting problem. F of x is equal to square root of x square plus kx plus 1 divided by x square minus k is continuous for all x belongs to R. Then find the interval of all possible values of k. If this function is continuous function for all x belongs to R, then you find the interval of all possible values of k. Okay. So clearly, according to the question, this function is continuous for all real numbers x means, that means the domain of this function must be equal to what? Capital R. So now this function is defined for all x belongs to R only when this denominator should not be equal to 0 for all x belongs to R. And x square minus k not equal to 0, it is possible only when k is negative. Because x square minus k not equal to 0 means x square should not be equal to what? K. So anyway x square cannot be negative. So that means k must be negative. If k negative, x square not equal to k is satisfied now. Next, one more condition. this x square plus kx plus 1 should be greater than or equal to 0 for all x belongs to R. This denominator not equal to 0 and this inside the square should be non-negative, greater than or equal to 0 for all x belongs to R. And here, what is the x square coefficient? 1, positive. And this quadratic expression greater than or equal to 0 for all x belongs to R, and the x square coefficient is positive. Both are possible only when the discriminant of this quadratic expression, should be less than or equal to 0. Discriminant b square minus 4ac less than or equal to 0. What is b square here? K square minus 4ac, 4 into 1 is 4. It should be less than or equal to 0. So k square minus 4 less than or equal to 0 means k square less than or equal to 4. So modulus of k less than or equal to 2. That is k is lie between minus 2 and plus 2. So from first condition k should be negative. From the second condition k should be lie between minus 2 and 2. So from 1 and 2 what is the common? What is the common? So minus 2 less than or equal to k less than 0. That is k belongs to left closed right open interval of minus 2 comma 0. Next you take one more homework problem. F of x is equal to x power 4 minus 256 divided by x minus 4 comma x not equal to 4, and its value is k for x is equal to 4, is continuous at x is equal to 4. Then find k value. Simple problem. Equate limit of the function is equal to value of the function. Write first that step and find limit of that function. So you will get 0 by 0 form, then you can use the L'Hospital's rule. So last problem I am going to discuss in this session. Okay. So it is look like very difficult, but it is so easy problem. F of x is equal to a plus 3 cos x divided by x square for x not equal to 0, and b into tan of pi divided by step of x plus 3 for x is equal to 0. If it is continuous at 0, then we have to find a and b value. It is given it is continuous at 0, we have to find a and b values. See Rana, here when x value exactly 0, this is the function. That means what is f of 0 is given b into tan of pi upon step of x plus 3. But what is x value? 0. So here x value is what? 0. What do you have to put? X value 0. So integral part of 0 plus 3. 0 plus 3 is 3. Integral part of 3. Step of 3 is 3. That means it becomes pi by 3. So what is pi by 3? Tan pi by 3? Root 3. 0 plus 3 is 3. Step of 3 is 3. Pi by 3. Tan pi by 3. Root 3. So f of 0 is b root 3. Next. Now as it is continuous, equate value of the function is equal to limit of the function. So limit extends to 0. A plus 3 cos x divided by x square is equal to b into root 3. So it is also just like a previous problem, that a sin x plus bx cos x, a cos x plus bx sin x, that problem is then just like that problem only. Here if you apply the limit, what you are getting? Numerator a plus 3, denominator what you are getting? 0. If you apply x tending to 0, then numerator is tending to what? A plus 3. Denominator is tending to what? 0. But limit of the function is given what? B root 3, finite. So when extending to 0, a numerator is a plus 3, denominator is 0. Suppose if a plus 3 is not equal to 0, okay, then what you will get? If a plus 3 not equal to 0, then what you will get? A plus 3 by 0, which is infinite, infinite. But here what we have, it is some finite quantity. So that means this is not equal to 0 assumption is wrong. A plus 3 must be equal to what? 0. And limit of the function is equal to what? B root 3. Okay. So a value what you will get? Minus 3. Substitute here and once again calculate, you will get b value. This is one method. Better I will go for expansion method only. So if I do expansions, again if I explain this method, again you may get confused, and that is why I am again going for expansion method only. So limit extends to 0. A plus 3 into cos x, expansion is what? 1 minus x square by 2 factorial. Denominator highest exponent is what? 2. So remaining terms you can neglect here also in the expansions. Okay, because if you write also no use, because remaining terms becomes 0 only. So now numerator is a polynomial, collect the like terms. Constant term is a plus 3 into 1, a plus 3 divided by x square. Next x square term is what you get? Minus 3 by 2 into x square by x square. Okay, minus 3x square by 2, 2 factorial is 2, plus 3 into x power 4 by 4 factorial divided by x square, and so on, b root 3. So here x square get cancelled and here x square get cancelled. As extends to 0, these all terms becomes what? Tending to 0. So those terms not at all useful for us now. Leave it. Okay, because they are all tending to what? 0. Now here come to this point. If a plus 3 not equal to 0, then what you are getting? Non-zero by 0, infinity, which is not possible because it is equal to some finite quantity b root 3. That means a plus 3 must be equal to what? 0. So a plus 3 must be equal to what? 0. And if a plus 3 is 0, then this term is also 0. And what is the left? Minus 3 by 2. So limit extends to 0, minus 3 by 2 is minus 3 by 2. So what is the limit of the function? Minus 3 by 2, which is equal to b root 3. Which is equal to b root 3. So thus you got a value minus 3 and b value minus root 3 by 2. Thank you.